So as you've seen from our previous section 7.1, multiplying and dividing fractions isn't so bad. It's just multiply the top parts and multiply the bottom parts. In our upcoming sections, what we're going to notice is that what you want to do before you think about multiplying and dividing is factor the top and bottom of your fractions as much as you can. So for example, in our first problem here, we have x plus y over 2x plus x times x squared over parentheses x plus y squared. Now on top of that first fraction, that x plus y, you can't factor that. So remember, when you have something with a plus or minus in it that you can't factor, it's good to put parentheses around it to remind yourself you have to treat it as a group. Now the great thing about multiplying problems is you can go ahead and just start reducing. Here, I notice that on the top of the first one, there's x plus y. On the bottom of the second one, there's x plus y squared. I can divide both of those by x plus y. I cancel out an x plus y from the top, and when I cancel out one x plus y from the bottom, instead of x plus y times x plus y, I'm just left with x plus y. In the same way, I notice I've got x squared on the top of the second one, and there's an x on the bottom of the first one. I can divide both of those by x. X divided by x, it just cancels out. X squared divided by x, I'm left with x instead of x squared. So here, all I'm left with on the top after that canceling out is x. And on the bottom, I'm left with 2 times x plus y, like that. Let's take a look at another multiplication example where we're going to factor first and then see what we can cancel out. So here on the top of the left one, to factor that, we're trying to think what can we multiply to get a positive 10 that would add up to a positive 7. It's going to start with x and x, and then to multiply to be 10 but add up to 7, you would need 2 and 5. On the bottom part of that same fraction, there's a greatest common factor. Both of those terms are divisible by 3. So we'd factor out a 3 to the front. 3x divided by 3 is x. 6 divided by 3 is 2. On the top of the second fraction, we've got a greatest common factor there as well. It'd be a 6. They're both divisible by 6. 6x divided by 6 is x. Minus 6 divided by 6 is minus 1. Then on the bottom of that second fraction, it starts with x squared, so we're going to have x and x. And then we think, what can we multiply to get negative 15 that adds up to a positive 2? It would be a positive 5 and a minus 3. So in these sections, you start the multiplying problems by factoring the top and bottom of every fraction as much as you can. Then look to see if there's anything that's a factor on the top and bottom that we can cancel out. The first thing I noticed, there's an x plus 2 on the top and the bottom, so I can cancel those out. There's also an x plus 5 on the top and the bottom, so we can cancel those out. Now there's nothing else that's exactly the same, but I do have some numbers, 6 and 3, that are both divisible by 3. So I reduce it by dividing them by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. Now there's nothing else I can do to reduce it. So on the top part, I have 2 times x minus 1 left over. On the bottom part, you would have 1 times x minus 3. Usually when there's a 1 you're multiplying by, people will just leave it out. So we just have x minus 3 for the bottom part of that one. Now, as you remember, when you're dividing fractions, the first step is to change it to a multiplication problem by flipping the second fraction. So here we're going to leave our first fraction alone, 5a squared b over 2, and we're going to change it to multiplying, and we flip the second fraction, 8 over 10a b squared. All right, so sometimes when you've got these problems with fractions and there's no adding or subtracting going on, it might actually be easier to multiply it first and then reduce it. Here on top, 5a squared b times 8, we would have 40a squared b. On the bottom, 2 times 10ab squared, we have 20ab squared. So looking at reducing this one now, the top and bottom are both divisible by 20. 40 divided by 20 is 2. 20 divided by 20 is 1. Looking at the a's, the top and bottom are both divisible by a. On the bottom, a divided by a, it cancels out. On the top, a squared divided by a is just a. Same sort of thing with the b's. The top and bottom are both divisible by b. On the top, b divided by b, it cancels out. On the bottom, b squared divided by b becomes just b. So looking at that, on the top, we've got a 2 times a left over. On the bottom, you have 1 times b, which is just b. Let's look at one more division problem. This one, when there is adding and subtracting going on, you want to factor it first before doing all the multiplying or dividing. So on the top of the first one, when we factor that, both of those terms are divisible by a. We can factor out an a. ab divided by a is just b minus a squared. When you factor out an a, you're left with a. On the bottom of that, a squared minus 1 is a difference of squares. The square root of a squared is a. The square root of 1 is 1. And then you put a plus in one group, a minus in the other group. Now, because it started as a division problem, we're going to change it to multiplication. And we're going to flip the fraction. So that a minus b that was on the top, now it's going to be on the bottom of the fraction. And a squared plus 2a plus 1, we're going to factor it and put the result on the top. And you know what? Just to make it visually easier, instead of the x for multiplication, I'm just going to put the dot. That makes me not get confused with the variable x for multiplying. So when we factor that a squared plus 2a plus 1, to multiply to be a positive 1, but add up to a positive 2, you would need a plus 1 and a plus 1. So when you're dividing, flip the second fraction, change it to multiplication, and you still factor all the parts. So let's see if there's anything that's the same on the top and the bottom here. We do have a plus 1 on the top and the bottom, so I can cancel those out. Now we don't have anything else that's exactly the same, but remember from one of our previous sections, a minus b and b minus a, those are the same except those are those subtraction opposites, subtraction where you change the order. And what we talked about is when you have those subtraction opposites, you can cancel them out, but when you do that, you have to put a negative sign at the front of your answer. So here, what we've got now that we've reduced everything we can, there's a negative sign at the front. And on the top of our fraction, we have a times a plus 1. On the bottom of our fraction, all we have left is a minus 1.